es Becka.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV. Hi, today we're going to talk a little bit more about quadratics. We talked in last video a little bit about quadratics. I'm going to give you some more information and hopefully we can build on what we learned last time. On my screen I've got just kind of a graphic that I'll talk about really quick about quadratics. There are three common forms of what a quadratic can look like. We talked last time about what makes a quadratic, which is this x squared, or this power of 2 here. We've got general or standard form of a quadratic that looks like this, y equals ax squared plus bx plus c. We also have what's called vertex or graphing form of a quadratic, which is really great if you are trying to graph a quadratic. It gives you a lot of good information that could help you graph something quickly. And then on the left we have what's called factored form. In our last video we looked at how to convert a quadratic from general form or standard form into factored form, and we use the Xbox factoring method. It's not the only method to do so, but this is one of them. So that's one that we did already. Today what we're going to do is look at converting something from standard or general form to vertex or graphing form with the method of completing the square. Part of the reason why it is important to know how to convert back and forth is just because different forms tell us different pieces of information. For example, vertex or graphing form tells us what the vertex is of our parabola or graph that this quadratic makes. So that's what we're going to get into today, is converting a quadratic from standard or general form to vertex and graphing form. Last time we also talked about this little piece here called the area model. We used it in our Xbox factoring method. We're also going to use the area model this time, so if you want a little bit more background information on how to use it, go check out the video on Xbox factoring. All right, so we're going to use this tool a little bit differently when we use the method of completing the square. So what we'll do is, to set this up, I've got this quadratic here in blue that's in standard form. It's x squared plus 8x plus 2. What we'll do to set it up is put the first term in the top left box. This is the same as the Xbox factoring method. Next, what we're going to do is this middle term, 8x, usually goes in these two boxes that I just put a dot in. And so we're still going to put it there, but what we want to do is we want to split it evenly, because we want our square here to actually be a square, not just a regular rectangle, but a square. And a square, what we know is that all sides are equal. And so we need what goes in these two boxes to be equal in order for it to be a perfect square. So we're going to take this 8x and we're going to divide it by 2. And that way we get the same number for each of them. So 8x divided by 2 gives us 4x. So we're going to put 4x and 4x in this box. Again, we want them to be the same because we want it to be a perfect square. From here now, we're going to find what our length and our width would be. We're going to use that. So we're looking for the things that multiply to equal this. Again, we talked about how this area model works in a previous video, the Xbox factoring video. So if you are unsure of how this works, you can go back to that video and that will give you a little bit more background. So we know that x times x should give us x squared, so that has to be the lengths of those sides. We know also that x times 4 has to give us 4x, and same down here, x times 4 gives us 4x. So our length is going to have to be x plus 4, and our width is going to have to be x plus 4. Our length and our width are the same, therefore it is a square. Now the issue is this, is normally when we use our area model, this last term here, that third term, that constant, is what goes in the box here. Now the problem is that if our rectangle here was a perfect square, that this area would not actually be 2 because the dimensions are 4 by 4. So if this were a perfect square, we would want the number in this box to be 16, 4 times 4. Now it's not, and so we're going to have to adjust things to help us handle that. So what we'll do is we're going to try to change this 2 to a 16 by adding 14. That would get us the 16 that we want it to be to make it a perfect square. However, if I add something to this equation, I'm now changing the equation. I'm kind of making it unbalanced because I'm changing it. I can't just do whatever I want to when it comes to algebra. I have to keep it balanced. So by me adding this 14, the only way that I can keep this balanced is by also subtracting 14. So now I'm kind of back to 0. So I've added 14 inside this square and subtracted it outside of the square to kind of keep it, again, balanced. Let me show you how this then plays out into our equation. So now, instead of calling my, my equation the area of it, I could call it the length times the width. This, again, is in the Xbox factoring video if this doesn't make sense to you, but I can call it the length times the width, which is now x plus 4 times x plus 4. But we also need to not forget that I subtracted 14. So minus 14 here at the end. Also, this is not quite graphing form. We want to actually rewrite this x plus 4 times x plus 4 as x plus 4 squared, and then we have our minus 14. Now at this point, you can see our equation is now in graphing form and looks just like that one. So this process right here on the bottom right, let me highlight this for you. This process right down here where I added 14 and subtracted 14, by me doing that, what I did is I completed the square. I found the missing piece that would make this a perfect square, a 4 by 4 square, and I added it to complete the square and then subtracted it to keep my equation balanced and keep my equation the same and equivalent as what it was before. So this method is just one of the methods to take an equation from general form or standard form to graphing or vertex form. But hopefully that helps and gives you an idea of one of the ways to do this.